Hello everyone. I think we are going to get started. My name is Anjali. I know it's lunchtime almost, and I wish this presentation was about, 3D printing food or getting us all not be hungry right now. But what we are going to talk about is Intel System Studio, which, as my colleague just mentioned, is a software tool intended to remove the obstacles that might come in a developer's way when doing IoT application development. And I'm going to go over a lot of features and a lot of things that Intel does to get everything ready for developers. And the bottom line is that we are trying to reduce the time to market or the time to adapt a particular technology or an idea. So if you're new to the IoT space and you're trying to learn something, if you are maybe teaching students and trying to get them to adapt to something, or you're bringing some new technology into your company, we are trying to cut down the time and effort it takes for you to get there. So there are many aspects of Intel System Studio. I'm not covering all of them. I'm just covering from an IoT application development point of view. The tool can also be used for system bring up, which is basically all these cool hardware boards that Tudor was talking about earlier. How do we perform on them? How does a particular software how do you debug something? How do you analyze it? All of those are some extra features that I'm not going to cover today. Looks like, okay. So Intel is part of an IoT Solutions Alliance, and maybe some of your companies are also part of that Solutions Alliance. And what the alliance is, that basically from the hardware level to the software and the customer service and the support level, we'll do everything. We'll talk with the ODMs and OEMs to get those boards ready. We'll work with projects like EMRA, UPM to get the sensors ready. We'll work with cloud service providers like Microsoft or Azure or Google Cloud to get the connectivity part ready, and we'll also address some security challenges that you might be facing. So we'll put all of this together and present to you as a company a combined solution that basically is taken care of. And on the right-hand side, you see that section about vertical operational technology experts. So that's where we'll set up the horizontal, and then all of the horizontal technologies can be applied to a vertical use case. I think the major ones right now in the IoT industry is retail, industrial uses, then we also have education as a big chunk, and all of one example of this end-to-end solution we call them developer kits, basically because they're enabling developers. And on the left, you see the software, again, Arduino Create and Intel System Studio, two very different type of softwares. And in the middle, you see the hardware. At the bottom is the IEI tank kit, and which is a very, very powerful kit which can be integrated with the SDKs you see in that column and be used for different applications. I'll talk a little bit about the SDKs if you haven't heard of them. First and foremost, we have OpenVINO Toolkit. OpenVINO is an open framework for vision and neural network optimization. And what it lets you do is really build and train AI models on the cloud and then deploy them to the edge. Then we have Intel Media SDK and Intel Media Server Studio, which is basically an SDK for, as the name says, by doing better image processing, better graphics, and faster media readiness. Then Intel also has an SDK for OpenCL applications and Intel AMT. This is, I think someone asked a question earlier. I have a factory situation. How do I deploy without disrupting everything? And AMT comes into the play there. If you have something really out in production and you need to do an out-of-bound service maintenance, or you need to do some repairs, AMT is basically a way to access those hardware devices remotely without causing that disruption. There's a very interesting, I think you can probably Google that story up, but in Germany, the government was really encouraging, like pretty much in the US, putting these photovoltaic solar generation devices at people's home. And in the beginning, it was never anticipated the rate at which it would increase. So all those tax breaks are luring people to, set up the solar panels in their homes. But now we have a problem that all of these distributed generation, how does it get back to further, the government was selling it further. So what the problem there was that the substation have these transformers or electrical devices that are not equipped, or they were never prepared for this kind of scale and in the reverse direction. And how AMT fixes that problem is that you can remote into the hardware devices without disrupting the flow and do that kind of management for the situation. The learning lesson is that from this point onwards, when we are designing these technologies, to keep in mind the vision that you can be prototyping something today, but tomorrow it can be in production. That's where the two IDEs come into play. The Arduino Create is a web-based IDE. I could load it. I'll not trust the internet, but it basically you just develop on the cloud, deploy on the cloud, build it on the cloud. And Intel systems, but you can do all of that prototyping, but eventually when you're putting it out in production, you want something which can, really go in fine grain, point out hotspots, point out problems, and help with maintenance. And with Intel System Studio, you can do all of that. And what's cool is that we have developed a bridge between the two IDEs. So you can develop something in Arduino Create and transfer it over to Intel System Studio using this bridge tool. I already talked about this, but it's basically a more detailed vision or a preview of how we have integrated with different ecosystem tools that a developer might require. There is a very tight integration between the EMRA UPM project and System Studio, and Intel System Studio being an IT based on Eclipse, there is a good integration with Eclipse plugins and extensions as well. So anything that you have used with your regular Eclipse IDE, you can very well bring it into Intel System Studio or vice versa. These are some things that I was talking about. I was talking more about the use cases, and here we have the specific things. So we have compilers and libraries for image, signal, math processing, data analytics, and IoT connection tools. And then you have the analyzer where you're checking for power and performance, and even balancing memory and thread management. There is the debugging part. I think I did not touch on that earlier. So we'll talk a little bit more about it later. So as Fred's survey was telling us earlier, connectivity, I think it was 21% of users are worried about connectivity. And IoT connection tools in Intel System Studio solves that problem. The sensors are one part where you are collecting, receiving data from the edges, receiving data from the sensors, and the edge sending data to the cloud is taken care of by cloud connectors. This is an example of how it looks within the IDE. So all of the companies that are contributing their sensors to the EMRA project or the UPM project, we have the infrastructure set up from that point to get them pulled into the IDE. And just by one click, you can insert this in your sample code. So reading the API documentation, everything is right there in the IDE. And if you are one of the sensor developers, it's one way to get your sensors or your APIs out to the audience very quick. We have a similar, we call it the Cloud Explorer, and this is for learning about what different ways you can use to connect your sample to the cloud. It's, all of these are obviously heavily based on MQTT, HTTP, some of them use Mosquito, and what these are here samples of how to get kicked off on that. And this is not going to directly translate into a product, but this is a step that can be in your product on how to solve the connectivity problem. So on this screen, I have a working example. I wish I had a video. All of the, so you can see Arduino create the ID. That's how it looks. And I wish, let me see if I have a cursor. This part here, is there a highlighter? Never mind. So all of the status logs on the left is data being sent to the cloud. And on the right-hand side, you can see that the data is being received. So this example uses Microsoft Azure. And I would say to set this up, to the time you get it running, max 15 to 20 minutes. And most of the time will go up in getting your passwords configured and set up. So after you have done that once, the setup time is really, really quick. You don't need to download anything. It's very fast. Another, sorry, this is very small. So what happens here is once you've gotten the keys and the login or any access credentials you need from the cloud, we have found a way to put that right in this while you are creating the project. So you don't need to change any code. You can just copy paste in the UI and you're good to go. This is another example of how AWS works on Intel System Studio. This is the AWS UI if you've used that, and it is telling us that data is being received. This is a graph showing the different ways data was received, and AWS has this really strong, or I think a very visually good way of telling you what was the failures, how many successful pings were there, how many good data transfers were there. So now we have got to a point where I've created an application and I'm collecting data from the sensor and I can send it to the cloud. But tomorrow I need to give it to my colleague who has a Mac and I'm working on Windows. How do you cross-compile? How do you make sure everything that's working on your machine will work on that target system you're going to deploy it to? For that, we use Docker containers. And all of the work that I was talking about can be done when you're creating your projects inside the IDE. You can do so, you can create them inside the Docker container. And within the Docker containers, we have CMake support, Makefile support, and we keep adding on new things. So watch out for that space. There's some really good, exciting stuff coming there. We also give the option of customizing what Docker image you're going to use. Docker is really powerful that way because of how it manages the layering system and saves you space and memory. So what we are seeing in this example is on the left, there are the 4 images that we ship with the product. And then let's say a user comes and they want OpenVINO, or they could want anything, any other new project, and they want to expand or extend that Docker image to have their own extra stuff. This is the tool to do that. You can add on to this and create your own Docker images, build your own projects, and then send those files over to your colleagues for it to just work out of the box. I know Eclipse CDT has, I think, in the just the most recent install, also added Red Hat plugin, which also helps with Docker management. And there are a lot of things that one can do by combining the use cases of both these plugins. So it's definitely interesting stuff. This is the debugging part. So I've given my my project now to my colleague there, and he needs to debug it, find the bugs that I've entered there. So we use use the Eclipse target connection framework, which is a pretty standard way of debugging application on the target. And the same method can be used for both system debugging, where you use JTAG, or just SSH IP-based debugging on Ubuntu targets. OpenVINO, we've been talking a lot about it, but that's because OpenVINO is really cool, and it lets you do a lot of things that in a very, very fast way. ISS and OpenVINO are very tightly integrated in the sense we have curated examples that use OpenVINO and show use cases out of the box. The image on the right is a result of showing the sample an image, and it's detecting what's the vehicle's make, model, color, and also the license plate. So Intel System Studio provides the Docker images for creating this, so you don't have to actually install OpenVINO to start working on this application. You just take the Docker image, build your sample on it. When you're deploying it, you would need the installation on the target, but there's a lot you can do before you reach that point. And it also allows you to share targets. So if, OpenVINO targets are typically expensive and need to be decently powerful. You can't do it on a light device. So if you're sharing something with your colleagues, you can do development on your own, and then both of you can use the same device to test things out. The we did some actually tests recently, and if you have used OpenVINO out of the box, from the command line it's very quick. But if you're using it in the IDE, we have brought down the time for this to, I've seen people do it in 40 minutes, 45 minutes, from the time they go, like find a project, oh, face detection is what I want to try out, to the time they see results on a target. And that's a very short deploy time. When I first tried it, it took me 2 days of work to just figure that out. The AI Vision Kit that Intel has, I think we had shown the image earlier, comes with ISS and OpenVINO preloaded on it, which basically means you don't even have to download ISS. It comes with a custom workspace. You don't even have to create the project or go through this step. It comes with that sample also, all done for you. So taking very good care of all the laziness out there, and avoiding any work that you might need to do on this side, so that you can focus on doing actual innovation or trying out your idea instead of getting stumbling on these blocks. I think one thing I forgot to mention was the languages, and we support, I should have started with that, we support C, C++, Java, and Python, the 4 top languages found in the developer survey for edge devices. And I think that covers everything I wanted to share about Intel System Studio. Questions? I zoomed through it. Yes?
How is it different from Visual Studio? How is it different from Visual Studio?
It's more IoT focused, and it's a Java-based tool. So if you're using Eclipse already and not using Visual Studio, then it kind of expands, builds on top of Eclipse. We also have Visual Studio plugins for Intel System Studio. So Intel System Studio, I focused on the IDE part because that was the application development side, but it's a software suite. And we provide Visual Studio plugins that are also branded as Intel System Studio.
But then we can say that when you use the Eclipse-based version, you can work on Linux, Windows, and Mac exactly the same way. So that's one big advantage.
Yes. Thank you for adding that.
So one question that I would have personally, your colleague gave us a bit of a hint about the upcoming roadmap for EMRA and UPM. So what's on the System Studio roadmap? What's coming in the next few months?
I can't talk much about that.
It's always the case, but can you give us a small peek at least?
So we really want to solve problems with, I mentioned the Docker part already. And then we are trying to, also trying to focus on workload consolidation and some stuff to do with making things more uniform. Sorry, that's the best I can say right now.
All right.
Turo, do you want to add something?
It's okay. I worked for big companies before. I know how it is.
It's going to be exciting. That's all I can say. Yeah.
Any more questions?
Could you go over the testing part of how the whole framework can help in terms of testing?
Actually, that's
I think I
do you mean debugging?
Not necessarily debugging, just like having test cases, and I'm not familiar with that part, to be honest, much.
Eclipse actually has, I think, good support for that. We use, in our team, we use Mocha plugins, but Intel System Studio in itself does not provide any extra testing support. We have analyzers, so you can identify what are the hotspots in the code, how will we optimize that. The software suite comes with vTune, and vTune is great for finding out what node or network layer is your application having latency at and how to solve that. But testing is not one of the items covered by us right now.
I guess was it MRR project that was, he was talking about some mock data. Would that tie into the edge so that like you can do the testing?
It could, yeah. Mock sensors. So for example, in the items I showed you where the cloud, we were sending data, right? That's all mocked data. It's nothing, it's all mocked sensors. There's no actual hardware. We are using that because when people are learning about cloud, sending data to the cloud, they might not have the hardware problem. So it's focusing on one problem at a time. And it goes the other way around. So if you're talking about sensors, and then we mock out the cloud part. Yeah.
No more questions? All right. Thank you very much.
Thank you.
So you have roughly over an hour to have lunch and chat. Obviously, don't hesitate to grab our presenters before they leave, if they have to leave, if you have additional questions or want to start making connections. Thank you and see you later.